Hi everyone, Chapter 4 Chemical Bonding 4.1 Lewis Structure Part 3. In this topic, you will learn about the resonance structure. Resonance structure we refer to the two or more Lewis structure for a single molecule that cannot be represented accurately by only one Lewis structure. It refers to the same relative placement of atoms but different locations of bonding and lone pairs electron. For the example, molecule of ozone. So there are 3 oxygen atoms in a molecule. This is not the exact Lewis structure for the ozone. Okay, so by using the 4 steps to draw the Lewis structure, remember, firstly, you have to count the total valence electron. So one oxygen atom, it has 6 valence electron. If there are 3 oxygen atoms, means that the total valence electron in ozone is 18 electron. Okay, then you form a single bond between the oxygen atom. Okay, single covalent bond. So one single covalent bond equivalent to 2 electrons. If there are 2 single covalent bond equivalent to 4 electrons. So minus 4 for the bonding pair electrons, and the balance is 14 electron. Next, you have to complete the lone pair on terminal atom. So each of the oxygen for the terminal atom, it has 3 lone pair equivalent to 6 electrons for each atom, and the total for the 2 surrounding atom is 12. Okay, 2, 4, 6, 8, 10 and 12. So minus 12 electron for the lone pair electrons on the surrounding atom, and the balance is 2 electron. So these 2 electrons, okay, you put as a lone pair on center atom, just like this one. Okay, and oxygen is categorized as a octet. And if you can see that both of the terminal atom are octet because around the oxygen atom has 8 electrons. 2, 4, 6, 8. Same for this oxygen. But for the center atom, this oxygen, it only has 2, 4, 6. And it is not octet. So how to make this oxygen or this center atom, okay, to be octet? So the terminal atom, okay, it can share one of the lone pair, okay, by forming bond with the center atom. For the example, okay, this terminal atom, okay, it will share or use its lone pair, one of its lone pair, to form bond with the center atom. Because to form one covalent bond, it needs 2 electrons. So this terminal atom, it will using 2 lone pair electrons, okay, to form bond with the center atom. So this is the molecule form, okay, when the oxygen share its lone pair electrons. Next, the other oxygen atom, this terminal atom, it also can share one its lone pair electrons, okay, with the center atom, and the double bond will form at this part. So this is a different structure. Okay, we have the structure 1 and we have the structure 2. The difference is the positions of the double bond. For the structure 1, the double bond is at this part, but for the structure 2, the double bond at this part. But the arrangements of atom are same, only the positions of the double bond are not same. So these 2 structure, actually the structure 1 can be structure 2 and the structure 2 can be structure 1. how it happened. Alright, so this we call it as a resonance. So to show it is resonance, we use the resonance arrow. So this is the resonance arrow. When you draw the Lewis structure, and if the structure has a resonance structure, so you have to put this arrow to show the relationship between the structure 1 and 2. It is resonance structure. So by using this arrow, then you can see that the structure 1 and 2 for the ozone, actually it cannot accurately represent the ozone molecule. For the example, you cannot assign a structure 1 as a Lewis structure for the ozone. Okay, or you assign only structure 2 as a structure for the ozone. Actually, both of the structure are Lewis structure for the ozone. So how to show these two structure as a Lewis structure for the ozone, or to show it has a resonance structure? So you have to draw both of the resonance structure, and then you showing the connections between these two molecules by using the resonance arrow. Because actually to show that the bonding electrons is delocalized, actually it has the resonance hybrid for these two structure. So this is a resonance hybrid for the structure 1 and 2. It shows that you can see there are dotted line here. Dotted line here shows that the bonding electron, this one, the double bond, it can be delocalized, and it can be here at this part. So it will produce structure 2. For you, when you want to write or draw the resonance structure, you have to draw this one. Not the resonance hybrid. This resonance hybrid, I just want to show you how the resonance hybrid for these two structure for the ozone, and how the electron the electron is delocalized. It happens when this oxygen it use its lone pair to form bond with the center atom. So this when it form bond with the center atom will be more than 8 electrons, because it has if here double bond, so it will have 2, 4, 6, 8 and 10 electrons around the oxygen. So this bonding, one of the double bond, it will form lone pair on this oxygen. So this is lone pair form when the double bond it use the double bond to form back the lone pair on the oxygen. So here is the double bond form when this lone pair is used to form double bond with the center atom. So that's how the electrons is delocalized in the molecule. Next, let's see another example. Here, this one is the question that I take from the lecture notes. So the calcium carbonate is a chemical compound with the molecular formula calcium carbonate, and it is formed by 3 main elements: carbon, oxygen and calcium. It is a common substance found in rocks in all parts of the world, and is the main component of shells of marine organisms, snails, coal balls, pearls and eggshells. So calcium carbonate is the active ingredient in agriculture lime, and is created when the calcium ions in hot water react with the carbonate ions creating lime scale. So what are the resonance structure for the carbonate ion? So this is the example. It needs you to draw the resonance structure for the ions, which is negative ion and ion, and it is a polyatomic ions, okay, because it has more than one types of the elements. Okay, it has carbon and oxygen. So as usual, okay, firstly you have to draw the Lewis structure of the calcium carbonate. So this is the Lewis structure of the calcium carbonate by using 4 steps in drawing the Lewis structure, but this is not the exact Lewis structure for the carbonate. If you can see that the oxygen, the surrounding atom, okay, or terminal atom, all the oxygen are octet because there are 8 electrons around each of the oxygen. So for the example, I took this one, 2, 4, 6 and 8. Okay, same for the other oxygen. But you can see that the carbon is not octet. Okay, carbon is categorized as octet, must be 8 electrons around it. But here you can see that there are only 6 electrons, 2, 4, 6. So only 6 electrons. So how to make it octet? Okay, let's say the oxygen, this oxygen, it will use one of the lone pair to form bond with the carbon. So it will form this Lewis structure. So you can see that when it forms double bond, so around carbon there are 2, 4, 6 and 8 electrons. And if this oxygen, okay, it used its lone pair to form bond with the carbon, so it will form this Lewis structure. And because it has 3 oxygen, so let's say the last oxygen terminal atom, okay, use its lone pair to form bond with the center atom. So this is the Lewis structure for the carbonate ion. So there are 3 Lewis structure for the carbonate ion. So what is the relationships, okay, between this Lewis structure, these ions? It is resonance structure, because you can see that the positions of the carbon and oxygen are same, but the difference is double bond. Okay, double bond and bonding pair and the lone pair. So it will make the carbonate ion exist as a resonance. So how to show these 3, okay, ions of the Lewis structure is a resonance. So we use resonance arrow. Okay, then okay, so actually this Lewis structure, it can form the second Lewis structure, which is the double bond. Okay, oxygen will use one of the double bond, okay, to form lone pair on this oxygen, so this one. Okay, and then this oxygen, okay, when the double bond is used to form the lone pair, it will make the carbon not octet. So this oxygen, okay, will take part, which is it will use one of the lone pair to form bond with the carbon, okay, to make sure that the carbon is octet. So it will form the second structure. Okay, and actually for this one, okay, it can form the third structure when the lone pair on the between this oxygen and carbon, it is used to form lone pair on the oxygen. Okay, and then the carbon will not be octet. So what happened? This oxygen, it will share one of the lone pair to form bond with the carbon. So the double bond is formed here and make the carbon is octet. So these 3 Lewis structure of carbonate ion is a resonance structure. because the electron, okay, lone pair and the bonding pair can be delocalized to form the other Lewis structure of the carbonic ion. So the carbonic ion cannot represent by only one Lewis structure, okay, because it has another two, which is the total structure to form as a resonance is 3. So this is a 3. I mean that this is a Lewis structure for the carbonic ion, and it exists as a resonance because okay, the lone pair and bonding pair cannot can be delocalized, okay, and form the other Lewis structure. So let's see another example. Okay, this one is the nitrogen dioxide. It's a chemical compound with the molecular formula NO2, and it is one of the several nitrogen oxides, and nitrogen dioxide is an intermediate in the industrial synthesis of the nitric acid, millions of tons of which are produced each year. And this reddish brown toxic gas has a characteristic sharp beating odor, and it is a prominent air pollutant, okay, and it needs to draw, okay, the Lewis structure for the nitrogen dioxide. So this is the Lewis structure for the nitrogen dioxide. So if you can see that nitrogen and oxygen is categorized as octet, and the oxygen as a terminal atom, okay, both of the oxygen are octet because there are 8 electrons around the oxygen, but nitrogen, it has lone electron. Okay, right now it's showing that there are 5 electrons around the nitrogen. Okay, so actually it can make near to the octet, which is it can form it can have another 2 electrons, okay, which is make it 7 electrons. Okay, so for the example, okay, this oxygen, okay, it will use one of the lone pair to form bond with the center atom, so it will form this structure. And another oxygen, okay, it also will share its lone pair to form bond with the nitrogen, so this is a second structure for the NO2. And then, okay, because the positions of the nitrogen and oxygen are same, but the difference is the locations or positions of the double bond, so it can exist as a resonance structure. These two structure, okay, can exist as a resonance structure. And okay, so this is what happened, okay, this structure can be produced when this oxygen, okay, it use one of the lone pair to form bond with the center atom. At the same time, okay, the nitrogen cannot be more than 8. So what happened, okay, this one of the bonding of the double bond, it will form lone pair on this oxygen, so this one, just like this one. So this is a 2 structure of the NO2. Okay, let's see, draw the Lewis structure for the NO3 minus. Okay, so this is a Lewis structure for the NO3 minus. So you can see that, okay, oxygen are octet, all the oxygen are octet, but nitrogen is not octet. So how to make it octet? Okay, all the oxygen, okay, it will share, okay, the lone pair electron to form bond. Okay, for the example, this oxygen share its lone pair and form the first structure. The second oxygen, okay, so it will form the second Lewis structure, and the third oxygen, okay, it will form this structure. So okay, by using the resonance arrow, okay, this is a relationship between these 3 structure. It is a resonance. Okay, and here, okay, I'm showing you how the electron is delocalized, which is one of the double bond, okay, one of the bonding is used to form lone pair on this oxygen. So here, and this oxygen is not octet, it will make the oxygen not octet. So what happened, this oxygen, it will use its lone pair to form bond with the center atom. So the double bond is formed here. So from this structure, it can form this structure, okay, because of the delocalizations of the bonding pair and lone pair. And this one also, the third structure, okay, same, which is this oxygen, it will use one of the lone pair to form the bonding with the nitrogen. So here it will become double bond, and the nitrogen cannot be more than 8 electrons around it. So this one of the double bond, okay, one of the covalent bond of the double bond, okay, it will form lone pair on this oxygen. So here, so this three structure, okay, it shows that how the bonding electron and lone pair is delocalized. Okay, this one is the example, okay, that I took from the past year questions, okay, 2017 and 18. So it given you the azide ion. Actually, the formula of the ion N3 minus, not N negative 3, it is N3 minus. So please do corrections, okay, in your questions. Then it needs you to draw possible resonance structure for the azide ion. So from the molecular formula, you can see that there are 3 same atom with the same electronegativity, nitrogen. So by using the 4th step to draw the Lewis structure of this compound, okay, which is you have to count the total valence electron, and then you minus the bonding pair electrons, okay, and then you minus the lone pair electron, okay, and then the valence you put at the center atom. So if you can see here, okay, the terminal atom are octets, but nitrogen for the center atom, okay, it is not octet, there are only 6 electrons. So what happened, okay, the terminal atom, okay, it will take part by sharing its one of the lone pair with the center atom and form double bond, just like this one. And then, okay, the another terminal atom, it also can share its lone pair to form bond. So when it form these two structure, okay, these two structure are resonance structure, and to show the connection between these two structure by using the resonance arrow. And this structure, it can form this structure when the lone pair or the bonding pair here, okay, it will form lone pair on the nitrogen, so it will form lone pair here, and then this nitrogen, okay, it will use one of the lone pair to form bond with the center atom, so double bond will form here. So delocalizations of the bonding pair electrons and lone pair electrons, okay, will produce this structure. So relationship between these two, okay, we call it as the resonance structure. Okay, that's all. Thank you.